All right. So again, my topic for today's presentation is tracking efforts toward meeting Iowa nutrient reduction strategy goals. So I'm the measurement coordinator for the Iowa nutrient reduction strategy, and a big part of what I do is help us to visualize what steps are we taking at the statewide scale to help us reduce nutrient losses and improve water quality. So we'll get started, talk a little bit about the Iowa nutrient reduction strategy, just a little overview of what this is. Um, so the 12 states along the Mississippi River were tasked to develop comprehensive nutrient reduction plans by the 2008 Gulf Hypoxia Task Force. And so each of these states came up with their own plan here. And so the Iowa nutrient reduction strategy is, to quote, a science and technology-based framework to assess and reduce nutrients to Iowa waters in the Gulf of America. So our goal is to eventually achieve a 45% reduction in total nitrogen and total phosphorus loads compared to the baseline period level, so those average annual loads during the period 1980 to 1996. So as part of developing the Iowa nutrient reduction strategy, we're looking at two different components here. We're looking at point source contributions to nutrient loading as well as non-point source contributions. So a technology assessment was conducted to help better understand the feasibility of making changes to water treatment plants and help reduce nutrient discharge there. So that point source technology assessment, seeing what kind of modernization or improvements were needed at various locations. And the other component of that is the non-point source science assessment. So looking at what practices we're using on the landscape and the contributions that they can potentially have in reducing nutrient loss through use of agricultural conservation practices. Okay, so we have these goals. How do we assess what progress we're making towards tracking or towards meeting these goals? So part of the Iowa Nutrient Reduction Strategy Measurement Project is helping us, again, quantify these various steps that have been taken towards making change. So what we have here is the logic model that helps us sort of guide our thinking towards evaluating change or how we can evaluate change. So we look across four different measurable dimensions. We're looking at inputs, first of all. So thinking about what kind of staffing, what kind of funding, agency resources are being dedicated to water quality improvement and nutrient reduction. We're looking at what we consider the human indicator, which throughout the years we've tracked various things. We've engaged in various different activities, such as surveys where we're actually collecting people's knowledge about the nutrient reduction strategy back when it was back in the early years of the nutrient reduction strategy, sort of seeing what people knew and what their attitudes were towards the nutrient reduction strategy. Currently, what we're really focused on with the human indicator is tracking what sorts of events, so thinking about educational events, field days, things like that, are occurring around the state that focus on helping us meet nutrient reduction strategy goals and how many people are attending those events. So how much of the public is being aware of it or is engaged in these activities. As far as the land indicator goes, we're looking at point source implementation. Are we meeting facility improvement goals? Looking at current land use and land use change over time. So what are we doing on the landscape? And then the extent of conservation practice adoption. What does that look like now? How has that changed throughout the years? And then finally, we're all sort of leading to the point of water quality. What's happening there? So we're three main things that we're looking at on the dashboards for water quality is looking at what sort of monitoring is occurring throughout the state, looking at measured nutrient loads at the statewide scale and in priority watersheds, and also modeled water quality improvements associated with conservation practice implementation. So again, we've got this logic model laying out these four steps, and we see the arrows sort of connecting one of these to the other because we know that in order to see large scale water quality improvement, we're going to need increased inputs, which will hopefully then lead to increase in the number of people who are engaging in water quality improvement practices and educational opportunities, an increase in beneficial land management practice adoption, and ultimately then improved water quality. So clearly there's a lot going on there, and I'm just giving a very brief overview. But where do these data come from? So we're really fortunate that we have a lot of great partners to provide this information because we couldn't do this without the support of a lot of different collaborators. So we get data from reports from partner organizations and agencies. So that includes commodity groups. That includes groups like Iowa State University Extension and state agencies. We're looking at public information sources. So what is out there that's openly available online? So thinking about things like the USDA Census of Agriculture, National Agricultural Statistics Service, FSA data, things like that that we can all just access from our computers. And finally, we do get information from surveys. So one of our partners, the Iowa Nutrient Research and Education Council, conducts an annual survey at the statewide scale, looking at producers' adoption of different practices. So helping us to better understand distribution of practices like cover crop use, nutrient application rates and timing, things like that. So again, we're taking data from all different sources and bringing it together to help us get a better big picture understanding of what's happening at the statewide scale. Okay, so I'm talking about all these data, but what does it look like? We'll take a real quick trip here, and hopefully this will work for us. And we'll actually take a look at our data dashboards. So did this all move successfully? We can all see this, hopefully. All right. So I've taken you to our website, Tracking the Iowa Nutrient Reduction Strategy, and this is our data dashboard page. So we'll just go really quick. You'll see that of the 4 indicators that I mentioned previously, we do have dashboards corresponding to all of those. We actually have 6 dashboards, but they correspond to all 4 of those indicators. But the 3 that I really want to talk about today, because these are the ones that I'll highlight in my presentation, are the bottom 3, tracking land use and in-field practices, tracking edge of field and erosion control practices, and tracking water quality and nutrient export. So I'm going to very quickly open up each of these, and we'll just take a really quick look, and that top bar is going to get in my way. So there's a lot here. It looks different on every screen you display it on, but I'll just click on a couple things so we can take a look. So right here, I've just clicked on the one where we can look at Iowa agricultural land use since 1980. So we can look at how those trends have changed over time. Cover crops, extent of cover crops, looking at numbers that we have from different data sources. Here we've got information about tillage that we have from the Census of Agriculture. There are different maps that you can explore there. Down here we've got data. Again, these are all things that I'll talk about in a little more detail later on, but we've got data showing, for example, the distribution of acreage using different commercial nitrogen fertilizer application rates. So really doing the best we can to track as many different metrics as we can that are related to water quality. Similarly, here, when we switch over to the edge of field and structural erosion control practices, we've got here, for example, this is just our table on cumulative acres protected by bioreactors, saturated buffers, and multipurpose oxbows since the early 2000s. We have those numbers annually as well. Again, maps, different ways of displaying the location data there, and then we also have data on water quality wetlands and some of those structural erosion control practices that I'll talk about later on. I know this is a lot. I just want to give a very brief overview of what you could see if you decide that you would like to take some time in the future and check out these dashboards. Finally, just a couple things here on the water quality front. So similar calculations for nitrogen and phosphorus. We have flow-weighted nitrate load, as well as tabs that provide description and context for the data that we're seeing here. We have our tab on water quality monitoring, which I will return to later on, which got a bunch of information here, and I'll talk through this in detail in my presentation. But again, the interactive maps, and you can click on all these things and get more information. More information about precipitation and water yield in this panel here. And here we have our modeled nutrient loads. Again, I'll return to that. But I apologize. Got lots of windows going here. Okay, so very, very quick tour of the dashboards. But that's just to illustrate sort of how we're displaying these data. What practices are we tracking? So first of all, as much as we'd like to be able to display everything about everything, we always want that, right? But we don't know everything. So what we're able to track and quantify and put up on the dashboard is a subset of Iowa nutrient reduction strategy practices. So back when the Iowa nutrient reduction strategy was first developed, the science team underwent a process where they reviewed a number of different conservation practices and looked through literature from Iowa and surrounding states. So looked through that research data and looked at the effectiveness of those land use practices in reducing nutrient losses. And so that data was compiled and brought together, and that's what's included in the strategy as practices that have been proven through research to be capable of reducing nutrient losses. Again, of all of those practices, we aren't able to quantify all of them. So, for example, practices like shallow drainage or drainage water management, it's a lot trickier when it gets into understanding things that are underground, right? I mean, for shallow drainage, of course, that's something that is not visible from the landscape. We're not sure what's happening there. So at this time, we're unable to track practices like that people are putting on their own operations, and we have no knowledge of that. And the same goes for all of the practices that we're tracking. We use the best information that we have available to us, but we know that we can't possibly capture everything that's happening everywhere. We do our best. So I'll talk a little bit about those specific practices that we do have data on and where those data are coming from. And then moving or thinking forward to the next couple of slides of my presentation, we'll talk about how we're actually using these data to estimate the contributions of these practices that people are putting on the landscape to reducing nutrient losses in Iowa. So a couple different land use practices that we have here. Of course, we saw previously, I showed the graphic from the dashboard on agricultural land use and distribution of that. And so we have data on that from the USDA Census of Agriculture, from NASS, and from FSA. And so you can see, depending on the crops that we're interested in, we can get data from different sources. Again, with the Census of Agriculture, we do use that when it's available, but we know that the Census of Agriculture is only conducted once every 5 years. So in some cases, we're only able to get data on certain practices once every 5 years, while other data that we get from different sources, we do have at an annual time step. We also track data on Conservation Reserve Program, acres, or land retirement, because again, that supports the Iowa nutrient reduction strategy in terms of taking less productive land out of production and allowing it to remain uncropped. Cover crops, we get data on cover crops from a variety of sources, as you saw briefly when we looked at the dashboards there. From the survey conducted by our partners, the Iowa Nutrient Research and Education Council, we have annual cover crop acres estimated from their survey. We have data from the state of Iowa on cost share acres and crop insurance discount program. And again, every 5 years, we include that ag census data. Reduced tillage, same thing. We have that survey that's conducted annually and census data every 5 years. And fertilizer application. So looking at the 4 R's for fertilizer application, because again, these are practices, we're looking at practices that support the Iowa Nutrient Reduction Strategy's approved practice list. NREC survey, we're looking at state fertilizer sales data to understand what's being purchased every year. And we do also use the Census of Agriculture to estimate. We actually use that for getting animal numbers, which are used to help us estimate manure contributions to nitrogen. And for our edgefield and structural erosion control practices, we have, as I showed previously, bioreactors, saturated buffers, and multipurpose oxbows, which right now these are practices that haven't been adopted in huge numbers. They're sort of more up and coming. And so right now we're able to, or we feel pretty confident that the numbers that we have up there are pretty close to the actual number of practices that are on the landscape. Based on the fact also that a lot of these, in contrast to infield practices, are practices that are expensive to install. And so people are likely relying on programs. We're really fortunate here in Iowa to have a lot of cost share support for installing practices like bioreactors and saturated buffers. And so we work with our partners at the Iowa Department of Ag and Land Stewardship to understand how many practices are being put in place and where they're being put in place. So we use that data. Iowa State University has also put in some of these things. And again, getting back to that sort of idea of personal communications, talking with conservation program staff and helping to better understand, is there anything that we're missing that they know about? Because these are, compared to infield practices, there are far fewer of these on the landscape, or covering a much lesser extent of the landscape. Water quality wetlands, we do offer our partners opportunities to share information about water quality wetlands, but right now the vast majority of practices come from the Iowa Department of Ag and Land Stewardship, so that's how we're able to track the extent of those wetlands. And then finally, grade stabilization, erosion control, things like that. We have state and federal cost share program data to help us quantify the extent of those practices. So we talked about land use practices, infield, edgefield kind of practices. And that's all interest, hopefully people are interested in that. But one of the biggest things that I think people are really using our data dashboards for is understanding water quality. So what do we include on the dashboards when it comes to water quality? Well, as I briefly mentioned earlier and showed this map very quickly, we have our measured data. So we have monitoring sites throughout the state. If you look at these purple and blue, and there are a couple green dots there, you can see these are all around the edges of the states. These are the monitoring sites that are near the state boundaries that are used to calculate and to help us estimate statewide nutrient loads. So there are 18 of these stations that are used in the calculation of statewide nitrogen load and 16 in statewide phosphorus load. And so we can see these outlines here are the watershed boundaries draining to each of these monitoring locations. So we can see that we have nearly the entire state of Iowa is covered by these monitoring locations. So again, our partners are really helpful in doing this. So the Iowa Department of Natural Resources does the statewide load calculations for nitrogen, and our colleagues at the University of Iowa do calculations for phosphorus. These nutrient loads are estimated based on USGS flow data and monitored nutrient data, which comes either from monthly sampling that's conducted by the DNR, or when it's available, they're the USGS sensors and University of Iowa's water quality probing data that provide us with real-time data. And so the real-time data is used when that's available, and when that's not available, monthly samples are used and they're extrapolated throughout the time period. And so that gives us the ability to, I say us, it's our partners, have the ability to calculate these statewide loads, which we then display on the dashboards, which I briefly showed previously. We show those annual loads and flow-weighted nutrient loads to help us track not only what the measured loads were in that year, but how they compare to loads in different years. And the final piece here is thinking about modeled nutrient loss, or rather the impact of different agricultural management practices on reducing nutrient losses. So again, models, we're doing our best to estimate these things. So the model that we use for nitrogen was developed originally for the initial Iowa nutrient reduction strategies estimates of nutrient load during the baseline period. So essentially what was done is taking information about land use during that time, taking information about nitrate concentrations in drainage water and water yield to streams in the state of Iowa. So taking that information, using that to calculate that baseline nitrogen load level, given what was occurring on landscape during that time period. And then taking a look again, going back to the literature and seeing what are the nitrogen concentrations, estimated nitrogen concentrations associated with these different practices. What is the extent of these best management practices on the landscape? And then can we give any nutrient reduction credit to use of those practices during that time period? So that was all used to help get an understanding of the baseline period load. So the approach that we use now to continue using that same model approach is we use the same model built for the baseline period conditions. And essentially what we're doing is thinking about if we use the same amount of cover crops during the baseline period that we're using today, how would that baseline period nutrient load be different? And so that's what we're looking at here in the graphics, is looking at losses compared to the baseline period loads, or increases compared to the baseline period loads. And so right here, I'm showing the 2022 data. We almost have the 2023 data completed. We're just waiting on the data for water quality wetlands. So I didn't want to put anything that's unpublished in this presentation. So right now we're just going back a couple of years for these estimates. But again, so we're seeing, okay, with the level of cover crops that were implemented in 2022, had these been on the landscape during the baseline period, our overall nitrate load would have been about 15,000 tons less. So our 5.3% reduction compared to the baseline period loads with baseline period conservation practices in place. We can look at these numbers throughout all of these different practices. Again, we're not able to complete modeling for all of the Iowa Nutrient Reduction Strategy approved practices because we don't have data on the extent of all of the practices included in the strategy. And even for some of those practices, it becomes even more challenging to model that in the existing space. So we're doing what we can with what we have here. But we do include a great number of the practices that I've talked about previously in this here. And so we can see that most of what we've done since the baseline period, or at least, looking at 2022, we always look at these things as a snapshot in time, has had a positive impact, right? This negative sign means we're reducing compared to the original period. But it is important to note that as we change our agricultural practices, we are putting more conservation on the landscape, which is a great thing. But we also are changing the intensity of our agricultural practices in some areas, in some places where we're seeing higher yields compared to what we were seeing during the baseline period, and that's resulted in use of additional fertilizer. And so we're seeing increases from other sources. So just something to keep in mind there. But this is our overview of how we're using the data that we've calculated or that we've collected throughout other stages of this measurement process to ultimately give us a better picture. This is what's really helping us say what impacts are the practices that we're putting on landscape having on water quality. And we do the best we can by modeling that, and we do the best we can by taking those measured statewide loads. For phosphorus, similar approach in the sense that we're replicating the approach that was taken by the nutrient reduction strategy science team back when it was first developed. And so our phosphorus modeling uses an adaptation of the Iowa Phosphorus Index, which is a field scale model that was adapted by the science team to be used at the major land resource area, which breaks down the state into several different areas. And so the modified phosphorus index is used to perform these calculations across the different land regions of Iowa, and then we aggregate those results at the statewide scale to arrive at the overall impact on phosphorus load at the statewide scale. Again, it's important to note that we can't conduct this for all practices, but doing the best we can here, and here are the practices that we do have modeled data available for. One final thing that I always like to note when I'm talking to people about modeled data is if you decide to go look at these in your own time later or whatever, just as you look at it with me right now, it's important to note that we can't just go ahead and add up all of these numbers and say, oh, wow, 4,000 plus 2,000 plus 113 plus, we can't add all those numbers and say this is the overall reduction associated with all of these practices. We have to treat each of these practices in isolation because we're unable to account for, at this current time, interactions between practices or the fact that using two practices in combination means that not each of them is going to have the same level of effectiveness if they were used standalone. For example, if we're using cover crops on a field that's intensively tilled, we're expecting they probably will do a better job or they will seem comparatively more effective at reducing erosion than using cover crops on a no-till field. So just little things like that to keep in mind that these practices are not completely additive, but we do know that in combination, we are seeing not necessarily the total magnitude here, but we're definitely seeing a positive trend here as far as nutrient reduction from using these conservation practices. Again, that's how that data is used to model phosphorus or to help us understand the contributions that we're making towards reducing phosphorus losses at the statewide scale. And then finally, I just want to bring things together by talking about how these data are used. So, of course, the measurement project, this whole effort towards transitioning from paper reports to these online data dashboards, they both have the same purpose, which is to provide updates on Iowa nutrient reduction strategy efforts and nutrient loss progress in Iowa, or nutrient loss reduction progress in Iowa. But importantly, having this different structure, having these interactive data dashboards is really great because it allows people to visualize the extent of agricultural management and conservation practice implementation in Iowa, helps us to see plainly laid out in a number of different ways resources that are being dedicated to nutrient reduction efforts, whether that's staff, whether that's funding, where those sources of funding, who's involved, and ultimately looking at statewide water quality over time and seeing where things are going. If you want more information about the Iowa Nutrient Reduction Strategy itself, you can visit the Iowa Nutrient Reduction Strategy at nutrientstrategy.iastate.edu. Or on the next slide, I'll have information for how you can get to the dashboards if you want to play around with that on your own. So QR code there will show it. And our website is nrstracking.cals.iastate.edu. So again, thank you for your time and your attention. And if we have a couple minutes for questions, I look forward to talking with you then as well.
Thank you, Elizabeth. That's a ton of good information. Sure. Yeah. And anyone has questions for Elizabeth?
Okay. It's like,
Oh, since chat, I think Allison, she has a question.
Oh,
Do
sure.
you have any tips for how to collaborate with others to get access to this level of data sharing agreement? I think Allison working on some project, a DIY project in Michigan. I think that's kind of interesting. This type of thing.
Mhm. Sure. And I can maybe offer a little bit of insight there. First of all, a lot of these data we're really fortunate to be able to access online through state websites, through federal websites. So that's always a good starting point if you're really just looking for the introductory baseline information. But it does get more challenging, especially with some of the things that I mentioned that I think are the things that people are really interested in, where I talked about like the having information on fertilizer application rates. We have nitrogen application rates, phosphorus application timing, things like that. Those are things that you're not going to get from just the generic. You can't go to the NAS website and get that information. And so the organization that we partner with, the Iowa Nutrient Research and Education Council, was selected as an organization to conduct the survey that we have. And it is, as Allison mentioned, a sort of a data sharing agreement in the sense that they were selected as sort of the right organization to partner with in order to gather the data because they're committed to protecting that personally identifying information. They're committed to adhering to our sort of rigorous guidelines as far as making sure that we're protecting confidentiality, making sure that we're gathering data at an appropriate scale, sampling equally isn't quite the right word, but doing a balanced sample to make sure that we're accurately representing the state as best as possible. So that is something that was conducted through an agreement. I this is not within the scope of my position, and this happened before my time, so I don't know that I have very clear guidance. But I'm not sure if Matt is still on the call here. I know Matt Helmers was on the call, and I'm sure Matt would have a much better response to this.
Hey, Elizabeth, and hello
Sorry to
to
put
all
you
the
on the
others.
spot there.
No, no, can you repeat that? I spaced out for a second, but I think I
Oh,
can
sorry.
help answer
Okay.
it. So,
Yes, so we were asked about if we have any tips for how to collaborate with others to get access to data at the level, like, for example, I talked a little bit about the INREX survey and how that's an agreement.
yeah.
They were selected because of their ability to protect confidentiality and all that. But any other suggestions for collaborating with people?
No, that we definitely did, and I think it's probably come down to, relationships and, kind of building that trust with folks. And one of the other things was that, I think it's at times, maybe in some states, it's been a challenge to get maybe information from NRCS, but it's worked pretty well in Iowa. But I think that's in part because of close working relationships between IDOLS and NRCS.
Mhm. Okay, glad to hear it was helpful, Allison.
Yeah. Um, since Matt here, I mean, the question probably for Matt as well. Kind of, I was just curious actually. Uh, I mean, it makes sense to me in terms of this kind of logical model for this for dimensions everything. So when you guys develop, I think Elizabeth mentioned some measure of the success committee. So who was involved? This committee kind of develop this kind of logical model.
Yeah, I guess I can answer that because I Elizabeth
You
was
were
in
there.
Ohio at that time, so or maybe in Iowa. Yeah. So with the Iowa nutrient reduction strategy, it's been a close collaboration of IDOLS, which is our representative to the Hypoxia Task Force Committee, and then Iowa DNR and Iowa State. And so I think there was maybe a committee that, and then there's also this Water Resources Coordinating Council in the state, which is made up of state and federal agencies, that kind of have some tie in with water resources. I think that measurement, kind of that process, that logic model came out of a committee that was set up as part of the WRCC, and it was kind of an ad hoc committee that was put together to kind of talk about how do we track progress. That committee was led by John Lawrence, that was the associate dean for extension and outreach in our College of Ag at that time, that kind of led the nutrient reduction strategy science team. And then I guess it kind of was bought in then from that point in time, at least by IDOL's DNR and Iowa State.
All right. Thank you. And then the other question. So we can keep a little longer. It's okay. I mean, it's half an hour, but yeah, that's interesting, and probably for both Elizabeth and Matt. I don't know who for you, but I noticed, basically the tracking the data. I think that for Ohio, we are particularly into the kind of phosphate, especially the SRP, which is a kind of big concern in the West Lake River Basin. So seems like you guys notice some pattern, like you see the annual loading or 5-year moving average kind of decreasing or something, but actually those increased or basically because one or few large event which has caused this kind of the phosphate loading spikes. That's kind of true in Iowa or.
So one of the things that I want to mention, if you are looking at the dashboards, one of the things that we do provide information on as well is precipitation during these years, because as you pointed out, it is oftentimes that it's just a few small storms or a few isolated incidents,
Mhm.
not necessarily small, that can contribute the vast majority of annual phosphorus loads, right? If you have a
Yeah.
couple big intense storms, that provides the bulk of the year's phosphorus losses. So one of the things that we can take a look at too, and that we have the data on the dashboards to show, is looking at precipitation data throughout the time, which of course doesn't give us a picture of intensity or distribution of precipitation intensity over time.
Mhm.
But we do see, for example, I mean, again, to bring it back to nitrate loads, you do see
Yeah.
that we had some drier years. And so the nitrate loads were lower as a result of that, because that's just, the nitrate
Yeah.
can't be transported if there's no water in which to transport it, kind of
Oh
idea.
yeah. Sure. Yeah, that's a kind of
Mhm.
high hydrology. That's a pattern kind of similar from doesn't matter it's Iowa or Ohio, kind of similar
Mhm.
pattern. And then
Mhm.
how you guys gonna in the future to kind of deal with this kind of large event things, or what kind of strategy in terms of agricultural practice you guys are planning to uh
And can I maybe make one comment on the monitoring quickly, kind of
yeah.
putting in on the side of our Nutrient Research Center. So we funded some work that Keith Schilling and Elliot Anderson did to relate phosphorus to some turbidity in various, because we don't have, kind of close interval phosphorus data on the large watersheds. And so they did some work, kind of surrogate methods for predicting at least total phosphorus from turbidity measurements in various watersheds, to try to be able to kind of better characterize some of those high flow events when we may not have, the physical sample out there. And it was kind of fortunate because they got some of those high intensity events during the period that they were doing kind of their close interval monitoring.
And thanks for pointing that out, Matt, because that is another thing that when we think about all the things we'd like to be able to display, that is kind of the sort of data that we're interested in. Again, because as Chang, you mentioned, it's not, it is those couple of events that aren't necessarily captured by all of our existing monitoring or by all of the monitoring that's used in these statewide load calculations. So it would be great to have that additional level of granularity that we'd be able to display to better illustrate that.